Section 2.5, Polar Bookshop, a cloud-native application. In this book, I aim to provide real-world code examples as often as possible. Now that you have explored some of the key concepts and have tried your hand at building, containerizing, and deploying a Spring application, let's take on a slightly more complicated project: an online bookshop. In the rest of the book, I'll guide you through developing a complete cloud-native system based on Spring applications, containerizing it, and deploying it with Kubernetes in a public cloud. For each concept we cover in the following chapters, I'll show you how to apply it to a real-world cloud-native scenario for a complete hands-on learning experience. Remember that all the code used in this book is available on the book's GitHub repository. This section will define the requirements for the cloud-native project we'll build, and it will describe its architecture. Then I'll outline the main technologies and patterns we'll use to implement it. Section 2.5.1, Understanding the Requirements of the System. Polar Bookshop is a specialized bookshop whose mission is to spread knowledge and information about the North Pole and the Arctic, where the bookshop is located, the Arctic's history, geography, animals, and so on. The organization managing the bookshop, Polar Sophia, has decided to start selling its books online to spread them worldwide, but that is only the beginning. The project is very ambitious, and the vision includes a suite of software products to fulfill the Polar Sophia mission. After the successful pilot project earlier in this chapter, the organization has decided to embark on a cloud-native journey. Throughout the book, you'll build the core part of a system with endless possibilities in terms of functionality and integration. The management plans to deliver new features in short iterations, reducing the time to market and getting early feedback from users. Their goal is to bring the bookshop close to everyone, everywhere, so the application should be highly scalable. With a worldwide audience, such a system needs to be highly available, so resilience is essential. Polar Sophia is a small organization, and they need to optimize costs, especially those regarding infrastructure. They can't afford to build their own data center, so they have decided to rent IT hardware from a third party. By now, you can probably recognize some of the reasons why companies move to the cloud. That's what we'll do for the Polar Bookshop application. Of course, it will be a cloud-native application. Books will be available for sale through the application. When a customer purchases a book, they should be able to check on the status of their order. Two categories of people will use the Polar Bookshop application. Customers can browse books in the catalog, buy some, and check their orders. Employees can manage books, update existing ones, and add new items to the catalog. Figure 2.14 describes the architecture of the Polar Bookshop cloud-native system. As you can see, it's made up of several services. Some will implement the business logic of the system to provide the functionality already mentioned. Other services will implement shared concerns like centralized configuration. For clarity, the figure doesn't show the services responsible for the security and observability concerns. You'll learn about them later in the book. In the following chapters, I'll guide you through Figure 2.14 in more detail, adding more information about specific services and adopting different points of view to visualize the system in its deployment stage. For now, let's look at the patterns and technologies we'll use in the project. Section 2.5.2, Exploring Patterns and Technologies Used in the Project. I'll show you how to apply specific technologies or patterns to the Polar Bookshop project when I introduce each new topic in the book. Here I'll give you an overview of the main concerns we will address and the technologies and patterns we'll use to accomplish them.
Figure 2.14, Architecture of Polar Bookshop. The cloud-native system comprises application and data services with different responsibilities. For clarity, the security and observability services are not shown.
Web and interactions. Polar Bookshop comprises several services that will have to communicate with each other to provide their functionality. You'll build RESTful services that interact synchronously over HTTP, both in a blocking way, using traditional servlets, and non-blocking ways, using reactive programming. Spring MVC and Spring Webflux, on top of Project Reactor, will be your main tools for accomplishing such a result. When building cloud-native applications, you should design loosely coupled services and consider how you can keep data consistent in a distributed system context. Synchronous communications can generate problems when multiple services are involved in accomplishing a function. That's why event-driven programming is getting very popular in the cloud. It allows you to overcome the issues of synchronous communications. I'll show you how to use events and messaging systems to decouple services and ensure data consistency. You'll use Spring Cloud Stream to implement data streams between services and Spring Cloud Function to define message handlers as functions. The latter approach could naturally evolve in serverless applications deployed to platforms like Azure Functions, AWS Lambda, or native. Data. Data is a crucial part of software systems. In Polar Bookshop, you'll use the PostgreSQL relational database to permanently store the data processed by the application. I'll show you how to integrate an application with a data source using Spring Data JDBC, imperative, and Spring Data R2 DBC, reactive. You'll then learn how to evolve a data source and manage schema migrations with Flyway. Cloud-native applications should be stateless, but the state needs to be stored somewhere. In Polar Bookshop, you'll use Redis to externalize the session storage to a data store and keep applications stateless and scalable. Spring Session makes it easy to implement clustered user sessions. In particular, I'll show you how to use Spring Session Data Redis to integrate the application session management with Redis. Besides persisted data and session data, you'll also deal with messages to implement event-driven programming patterns. Spring AMQP and RabbitMQ will be the technologies you'll use to do so. Locally, you'll run these data services in Docker containers. In production, you'll rely on the managed services offered by a cloud provider like DigitalOcean or Azure, which take care of critical concerns like high availability, clustering, storage, and data replication. Configuration. Throughout the book, I'll show you how to configure the services in Polar Bookshop in different ways. I'll start by exploring the options offered by Spring Boot properties and profiles, and when to use them. You'll then learn how to apply external configuration by using environment variables when running a Spring application as a jar and as a container. Then you'll see how to centralize the configuration management through a configuration server with Spring Cloud Config. Finally, I'll teach you how to use config maps and secrets in Kubernetes. Routing. Polar Bookshop, being a distributed system, will need some routing configuration. Kubernetes has a built-in service discovery feature that can help you decouple services from their physical addresses and host names. Cloud-native applications are scalable, so any interactions between them should take that into account. Which instance should you call? Once again, Kubernetes offers you a load balancing feature natively, so you don't need to implement anything in your application. Using Spring Cloud Gateway, I'll guide you through implementing a service that will act as an API gateway to shield the outside from any internal API changes. It will also be an edge service that you'll use to address cross-cutting concerns, like security and resilience, in one place. Such a service will be the entry point to Polar Bookshop, and it will have to be highly available, performant, and fault-tolerant. Observability. The services in the Polar Bookshop system should be observable to be defined as cloud-native. I'll show you how to use Spring Boot Actuator to set up health and info endpoints and expose metrics with Micrometer to be fetched and processed by Prometheus. You'll then use Grafana to visualize the most critical metrics in informative dashboards. Requests can be handled by more than one service, so you'll need distributed tracing functionality to follow the request flow from one service to another. You'll set that up with OpenTelemetry. Then Grafana Tempo will fetch, process, and visualize the traces to give you a complete picture of how the system accomplishes its functions. Finally, you'll need a logging strategy in place. We should handle logs as event streams, so you'll make your Spring application stream log events to the standard output without considering how they are processed or stored. FluentBit will take care of collecting logs from all services. Loki will store and process them, and Grafana will let you browse them. Resilience. Cloud-native applications should be resilient. For the Polar Bookshop project, I'll show you various techniques for making an application resilient using Project Reactor, Spring Cloud Circuit Breaker, and Resilience 4J to implement circuit breakers, retries, timeouts, and other patterns. Security. Security is a vast subject that I won't be able to cover deeply in this book. Still, I recommend exploring the topic, since it's one of the most critical software concerns nowadays. It's a pervasive concern that should be addressed continuously from the very beginning of the project. For Polar Bookshop, I'll show you how to add authentication and authorization functionality to cloud-native applications. You'll see how to secure communications between services and between users and applications. OAuth 2.1 and OpenID Connect will be the standards you'll rely on to implement such functionality. Spring Security supports those standards and integrates seamlessly with external services to provide authentication and authorization. You'll use Keycloak for identity and access control management. Also, I'll introduce the concepts of secrets management and encryption. I won't be able to go too deep into those topics, but I'll show you how to manage secrets to configure Spring Boot applications. Testing. Automated testing is paramount for the success of a cloud-native application. A few levels of automated tests will cover the Polar Bookshop application. I'll show you how to use Unit 5 to write unit tests. Spring Boot adds many convenient utilities that improve integration testing, and you will use them to ensure the quality of your services. You'll write tests for the various features used in Polar Bookshop, including REST endpoints, messaging streams, data integrations, and security. Keeping parity across environments is essential to ensure the quality of your applications. This is especially true when it comes to backing services. In production, you will use services such as PostgreSQL and Redis. During testing, you should use similar services rather than mocks or test-specific tools like the H2 in-memory database. The Test Containers framework will help you use real services as containers in your automated tests. Build and deployment. Polar Bookshop's primary services will use Spring. You'll see how to package a Spring application, run it as a jar file, containerize it with cloud-native build packs, run it with Docker, and finally deploy containers with Kubernetes. You'll also see how to compile Spring applications to native images using Spring Native and Graal VM and use them in serverless architectures, taking advantage of their instant startup time, instant peak performance, reduced memory consumption, and reduced image size. Then you'll deploy them on a serverless platform built on top of Kubernetes with Native. I'll show you how to automate the build stage by setting up a deployment pipeline with GitHub Actions. The pipeline will build the application at every commit, run the tests, and package it ready for deployment. Such automation will support a continuous delivery culture to bring value to customers quickly and reliably. In the end, you'll also automate the deployment of Polar Bookshop to the production Kubernetes cluster using GitOps practices and Argo CD. UI. This book is focused on back-end technologies, so I won't teach you any front-end subjects. Of course, your application will need a front-end for the users to interact with. In the case of Polar Bookshop, you'll rely on a client application using the Angular framework. I won't show you the UI application code in this book because it's out of scope, but I've included it in the code repository accompanying the book.